Okay, so today, first of all, hello everybody. This is Nishant on Math Explained by an Idiot. We're going to be doing how to find the relative minimum and maximum of a function. And today we're just going to do polynomials. I will probably make another video about just other functions in general, but it all works basically the same way. So in order to do this, at least for this one, you need to know how to find the derivative of a function. And you also need to know what the second derivative and first derivative of functions are. Okay, let's begin. So, here's our first function. X to the power 4 minus 3 times x cubed plus 6x squared minus 6x plus 1. You want to find the minimums and maximums of this function. So for this first one, we're going to start off with a graph. So we can do that. And minimums and maximums, we want x to the power of 4. And you can do this with me. Minus 3x cubed plus 6x squared. And it's a minus 6x. A good thing I checked. Plus 1. Okay, so I've just zoomed this out a little bit, because otherwise this would just skyrocket straight up. But now we can see, if we look around, it looks kind of like a parabola, a little bit more scrunched up towards the center. But it's not just because the scale. You can also see now it still looks kind of weird compared to a regular parabola. And that's because of the x to the power of 4 and the minus x to the power of 3. You also notice, if you've done calculus, that the slope of the tangent line will always be changing. And at one point, it's actually 0. And when we find minimums and maximums, you should also notice that this is the lowest point on this graph, and this is what we're trying to look for. So what we can do, we can take the derivative of this function. Now if we zoom in over here, you can see when at this minimum, the derivative of the function is 0. Which means the slope of the function at that point is 0, because that's what the derivative is telling us. And now what I can do is I can take the derivative of this function, so you can see something else. Now what you see over here, I mean this one, it might look totally unrelated, but at this point, so here, you notice that it's positive. And if you know what's first and second derivative do, this means it's concave up. And when the function is concave up, and hold on, so backtrack a little bit. What I mean by concave up is it's the open part. It looks kind of like let's first take an absolute value sign. That can help. Let's see the value of x. Reduce this down a little bit. So the triangle part, that part is going straight up, and when it's straight up like this, or in this case, x squared, we call this concave up. When it's like this, we call it concave down. And a function can have different periods of concave up and concave down. So let's get back to this. So this is just saying that the function is concave up at this point, meaning the acceleration is positive. So this can help us determine if it's a relative min, max, and where it is. So we want to find the derivative of this function. So let's do that. For x cubed, this is all just power rule, minus 9x squared plus 12x minus 6. There we go. We get the same thing as before. And we want to solve this. Yippee, that's fun. So what we're going to do is just going to use this approximation. But let's say we didn't have the graph of this. We just knew that our answer would be somewhere around here. How would we tell that it's a minimum or maximum? Well, we would take the derivative of this function, or the second derivative of the original function. Let's do that. 12x squared minus 18x plus 12. So now you see at this point, the derivative is positive, meaning our function is concave up at that point, meaning the point that we were just given is a minimum. The point we just solved for is a minimum. So let's do another one. So our second function is, oh, this one has only even powers, so this one will be interesting. X to the power of 8 minus 3 to the power of 6 minus 19 times x to the power of 4 plus 2. Okay. So first thing we should notice, this looks kind of wonky. It's kind of like teeth, like a vampire's teeth. It's like it juts down like a tooth and it goes straight back up. Now if we look at this graph, over here we should have a slope of 0. That is a relative maximum. This is all about relative min and max. Over here we have a relative minimum. You see over here it just slopes back up afterwards. Here it slopes back down afterwards, and here it starts sloping back up. So now what we want to do is find, well, we want to find the min and max of this function. Yep, and then if you look over here, we don't have any other min or max. That just might be hiding. So let's take this graph away. Hopefully you don't remember what points there were, because I don't think I pointed them out. And let's try to solve. X to the power of 7 minus 18x to the power of 5 minus 76 76x to the power of 3. That's it. So we have these three as our points. But we also want to know, are they minimums or maximums? So we're going to do this again. 7. Ooh, I did forget something. When you use power rule, you gotta multiply by the exponent. So yeah, this looks a lot more appropriate. So let's continue. 56x to the power of 6 minus 90x to the power of 4 minus 210 plus 18. I'm just quickly figuring out 76 times 3. So this is 228 x squared. And now you notice that all of our powers are even again. The first derivative, they were all odd. Second derivative, they're now all even. So what does this tell us at each point? Well, over here, it's clearly positive, so this means this is the relative minimum. To the right side, it's also clearly positive, so this is also a relative minimum. But at the center, it's kind of odd. Here, it's 0. So how do we tell if it's a minimum or maximum? Well, this is the sad part. We're going to have to guess and check on each side. So I think I can just turn this into a table. And now you can see. Oh, I should not be doing it with this one. We can actually check using the first derivative. So on one side, slope is positive. On the other side, slope is negative. And since we're going from positive to negative, that means this is a maximum where it shoots up, reaches 0, and starts shooting back down again. And now if we draw this out, we did find our minimums were here and here. This is not a maximum, this is a 0. And we had, these are our minimums, and we finally found our maximum over here. Okay, so let's now you've seen some complicated versions. Let's do this with something rather simple. We're just going to do x minus 1 squared. And now you're saying, clearly, it must be at this point, 1, 0. But now because the numbers are a lot smaller, we can do algebra with this. Let's actually make this to the power of 4. And that would just, this is our x to the power of 4 function. It just looks a little bit scrunched. So now we can start solving. Now let's try to find our relative min and max. So let's take our first derivative. In this one, I'll disable the graph. I think we can just solve it without x minus 1 to the power of 3. This is our first derivative. This clearly says that this equals 0 when x equals 1. Yep. And for our second one, let's take the second derivative. Oh, this should still be minus 1. Notice that chain rule doesn't really do much here because the derivative of the inside function is also 1. So all we're doing is just shifting the function over. This should be a 12. And this equals 0 at 1 as well. Now our problem is that once again we have a function where its critical point, or where it's equal to 0, the first derivative equals 0, is also where its second point also equals 0. This second derivative also equals 0. So we're going to have to solve again. Okay, so why am I always doing it with this function? We should do it with the first derivative. Okay, so at 0, our slope is negative 4, meaning it's shooting down. At 1, it's 0. And then at 2, it's shooting up, which means this must be a relative minimum. And if we go back to our graph before, we are indeed correct. Okay, so I hope you understand how to find the relative min and max of not necessarily a function at this point, but of a general polynomial. I hope that you're able to understand at this point. I'm going to make another video where you do functions other than polynomials. That's going to be interesting. Like and subscribe. Share this with friends who need help with minimums and maximums. And I'll see you soon. Bye.